At the beginning of November this year, auroras were observed at surprisingly low latitudes, south of Italy and the US state of Texas. Such phenomena indicate the impact of a solar coronal mass ejection on Earth's magnetic field and atmosphere. However, this spectacular light show did not reach the level of the one in 1872, when a massive solar storm occurred. The auroral display resulting from that event encircled the globe, producing auroras visible in places as close to the equator as Mumbai and Khartoum. How would solar storms affect communication networks? A team of scientists from 9 countries recently published a detailed study of this historically significant event, tracking its solar origin and extended terrestrial impact. Telegraph communications were widely disrupted by this storm. But in today's technology-dependent society, such an event would disrupt electrical grids and satellite communications. Their findings confirm that such extreme storms are more frequent than previously believed, notes Uric Alert. In the modern world, we are increasingly dependent on technological infrastructure such as electrical grids, communication systems, and satellites. However, this dependency makes us more vulnerable to the effects of large geomagnetic storms. The longer the power outage, the more society, especially those living in urban areas, will struggle to cope. Could we sustain life without such infrastructure? Well, let's just say it would be extremely challenging, explains Assistant Professor Hayakawa, the lead author of the study. He also emphasized that such storms could be powerful enough to disable the electrical grid, communication systems, airplanes, and satellites, in the worst-case scenario. Space weather events are a risk that should not be neglected. One of the most interesting aspects of the 1872 storm was that it likely originated from a group of medium-sized but complex sunspots near the center of the solar disk, as confirmed by analyses of solar records from Belgium and Italy. These findings suggest that even a group of medium-sized sunspots triggered one of the most extreme magnetic storms in history. Hayakawa and his colleagues expanded their investigations into historical auroras by scouring writings from libraries, archives, and observatories worldwide. They identified over 700 records indicating that the night sky was illuminated by magnificent auroral displays from polar regions to the tropics, up to about 20 degrees latitude in both hemispheres. This means that we now know the world has experienced at least 3 super geomagnetic storms in the last 2 centuries. Space weather events that could cause such a major impact represent a risk that cannot be neglected, scientists further emphasize.